In binomial distributions, it's also possible that you will have to find the mean and standard deviation when you are given values and not a distribution chart. Here's an example of that type. In a rural city in California, it is made up of 72.1% Latino, 12.6% white, 3.2% black, 8.4% Native American, and 3.7% other. A jury selection is about to take place. We want to find the expected mean and standard deviation for the number of Latinos on the jury. First, we need to find what is a success and what is a failure. Because I'm looking for the number of Latinos on the jury, success is someone who identifies Latino, and a failure would be any other ethnicity. Additionally, there are 12 people on the jury, so N is 12. The probability of success is 0.721 as the number of Latinos in the rural city. Now you can calculate the mean. Mu is 12 times 0.721. This gives us 8.7 Latinos. Remember, your rounding rule is one place more than the data given. To find your standard deviation, we need the square root of n times p times q. Remember that q is the complement of p. So our standard deviation is expected to be 1.6 Latinos. We now want to determine the range for significantly high and low values in deciding the number of Latino jurors in the usual range for the city. Remember that you are just working with two standard deviations away from the mean. You want to use the mean and standard deviation that you've already found in Part A. We will now have our range for significantly low and high values. Our range is between 5.5 and 11.9 expected on the jury. Now, in the city's history, we have 870 people who were actually selected for juries, and we want to know what is the expected mean and standard deviation for the number of Latinos on the jury for this population. Now, we've already calculated what we expect in general. Now they're giving us some actual raw data, and we want to know what should we actually expect based off of what was given. Your N in this case is 870 people. Your probability of success is still 0.721 since we're still working with the Latinos. We'll calculate mu as 870 times 0.721. That means we should expect 627.3 Latinos for our mean. To calculate our standard deviation, we'll take the square root of 870 times p times q. This yields a standard deviation of 13.2 Latinos. Again, if you're unsure of how to find q, remember that it is the complement of p. You're not required to show that subtraction, but if you need to, go ahead and do that. Now, based on the city's 870 citizens who served on juries, let's determine the range for the significantly low and high values of Latino jurors to see what is the usual range for the city. Now you're working with the mean and standard deviation of the given data, meaning the two standard deviations with the mean and standard deviation from Part C. That means our significantly low value is approximately 600.9 Latinos, with a significantly high value of 653.7 Latinos. That means that we should expect to see that range of Latino jurors. For Part E, it says researchers looked closely at the data for those 870 people who served on juries, and it was found that 275 jury members identify as Latino. Is this number usual for the number of Latino jury members? Remember, the whole point of finding significantly and low high values is to find these boundaries that will section off when we have usual versus unusual on our number line. We can then place 275 jury members along this number line. And in fact, 275 jury members would be way, way unusually low. So in fact, no, 275 Latino jury members is not usual. So if you were a Latino person in this city, you are likely not being tried by a jury of your peers.